Design of rainwater harvesting for a residential building in composite climate. Abstract rainwater harvesting is the process of collection of rainwater and recycling it for various potable and non-potable purposes. Today the water shortage crises are rising rapidly, and the main reason is due to lack of proper monitoring and controlling of water. This document has been produced to assess the effectiveness of rainwater collection system, the impact of implementing them on saving water and relieving water stress. It proposes the design of smart water management system based on IoT application which helps controlling and monitoring of rainwater with the help of Arduino UNO as a microcontroller, which helps in processing information received from various sensors such as rain sensor, ultrasonic sensor, flow sensor, leak detectors, etc. The sensed information is automatically updated on the user Android application through which the user can visualize and monitor the system. The literature review introduces all the hardware needed for the monitoring, such as Arduino UNO, rainwater sensors, servo motor, male-female jumper wires, flow sensors, ultrasonic sensors, leak detectors, and software components such as ThinkSpeak. The paper analyzes the feasibility of the two case studies and compares their viability in harvesting rainwater and reducing the dependency on groundwater supply. New innovative ideas of water monitoring are explored in both the cases. In the first case study of A's Rao City Villa building, municipal water supply is altered with rainwater supply. This is controlled with the help of control valve and ultrasonic sensors connected to Arduino board. In the second case study, the rooftop rainwater harvesting is done and the water after quality analysis is recycled for potable use. In both the case the systems are powered with the help of solar panels, which makes them more efficient. Two designs have been proposed on the site located in composite climate at Noida Sector 19. In the first case the design of rainwater recharge pits is done, which helps in recharging the groundwater. Further, for controlling the overflow of the water, the storage tanks are designed which supplies water for gardening and other non-potable uses. In the second case the design of storage tanks is done to recycle the water for various potable and non-potable uses after the segregation of water is being done on the basis of the quality parameters such as pH value, turbidity, etc. The system is altered with the municipal supply same as in first case study, and it gives total recycling of rainwater with no wastage. So the system becomes effective in storing rainwater and recycling it for various purposes. It helps in reducing the dependency on groundwater supply, maintaining the groundwater level in a region, and prevents overexploitation of groundwater demand by rising population. Keywords: Internet of Things, architecture, planning, ill-adressedly care, physically challenged, challenges, solutions. Introduction. Water conservation is critical because it is one of the most significant factors for all species survival. According to the Central Groundwater Board's estimates, underground water will be scarce in 15 Indian states by 2025, Verma, 2021. However, as per the report from Ministry of Environment and Forest, only 10 to 20% rainwater is harvested, Verma, 2021, in urban areas. It is seen that nowadays concrete structures are constructed everywhere, so it is not possible to recharge the water table by natural process of raining. The rainwater, being the source of fresh water, gets wasted as it goes to the drains, and it is becoming one of the major problem of the present and will result in even more critical consequences in the future. Therefore, a rainwater harvesting system is required in Indian household to conserve water. Population growth all over the world is causing similar problems, concerns of how to supply quality water to all. At present, the 21st century core problem faced by the world is water scarcity. The best way to get rid of it, to wisely catch the water, comes in the form of rain and drain them responsibly. The available ways of collecting rainwater are housetops and land surface. One of the most important underlying values in rainwater harvest is that it's an interesting technology and can't produce undesirable consequences. The present vital water crisis facing by India and globally, to sort out a solution there is necessity of continuous monitoring of underground water levels is needed. The present work suggests a way to integrate the rainwater pits and monitoring possibilities over the IoT, Internet of Things, for better understanding of groundwater recharge process through man-concerned acts like rainwater harvesting. The IoT is a network technology that monitor the status of cloud for software to analyze in real time and help determine action steps. This technology uses microprocessor, sensor etc. The sensor senses the data and then the sensed data is processed by the microprocessor. The processed data gets uploaded in the cloud for the users to view in mobile phones/websites. One of the rapid influence of the IoT is in the field of water monitoring and controlling system. It is because, in the present era, water is considered as the most significant and scarce resource. The society deals with too many challenges in managing and conserving the water. Hence there is a need to preserve the water for the future by monitoring the water carefully. Thus the main objective of the research is to describe the various means through which IoT-enabled water monitoring and controlling system is achieved. The research produces development of various technologies for capturing and retaining runoff, including that from rooftops and roads, using this as a valuable sources of water, and artificially recharge the recharge pits, and finally increasing the groundwater level. This can help in reducing the increasing demand on groundwater sources. 3.1. Synopsis. Aim. To design rainwater harvesting for the residential building of composite climate and smart monitoring of it using IoT, Internet of Things. Objective. To calculate the potential amount of water being collected from rainwater harvesting and finding significant reduction in water demand by recycling rainwater for residential apartment of composite climate. To study and integrate IoT to water management system for continuous and real-time monitoring and controlling of rainwater. Rationale. The concept of smart rainwater harvesting has only come in the form of ideas, but is very less brought into execution. Water shortages is common in densely populated sites, and typical system of rainwater harvesting is less likely to be used in today's modern built homes. Hence, even though rainwater harvesting can be very effective in these areas, it's not popular enough due to its method of implementation, which has not advanced with time. The roofs of a building shall be so constructed or framed as to permit effectual drainage of the rainwater therefrom by means of a sufficient number of rainwater pipes of adequate size, so arranged, jointed, and fixed as to ensure that the rainwater is carried away from the building without causing dampness in any part of the walls or foundations of the building or those of an adjacent building. NBC, 2016. The rainwater pipes shall be fixed to the outside of the external walls of the building, or in recesses or chases cut or formed in such external wall, or in such other manner as may be approved by the authority. NBC, 2016. Rainwater pipes conveying rainwater shall discharge directly or by means of a channel into or over an inlet to a surface drain, or shall discharge freely in a compound, drain to surface drain, but in no case shall it discharge directly into any closed drain. NBC, 2016. Whenever it is not possible to discharge a rainwater pipe into or over an inlet to a surface drain, or in a compound or in a street drain within 30 m from the boundary of the premises, such rainwater pipe shall discharge into a gully trap which shall be connected with the street drain for storm water, and such a gully trap shall have a screen and a silt catcher incorporated in its design. NBC, 2016. If such street drain is not available within 30 m of the boundary of the premises, a rainwater pipe may discharge directly into the curb drain and shall be taken through a pipe outlet across the footpath, if any, without obstructing the path. NBC, 2016. A rainwater pipe shall not discharge into or connect with any soil pipe or its vent pipe, or any waste pipe or its vent pipe, nor shall it discharge into a sewer unless specifically permitted to do so by the authority, in which case such discharge into a sewer shall be intercepted by means of a gully trap. NBC, 2016. Rainwater pipes shall be constructed of cast iron, PVC, asbestos cement, galvanized sheet, or other equally suitable material, and shall be securely fixed. NBC, 2016. The spacing will also be determined by the amount of slopes that can be given to the roof. The recommended slopes for the flat roofs with smooth finish would be 1:150 to 1:133, with rough stone/tiles 1:100 and for gravel set in cement or loosely packed concrete finish 1:75 to 1:66, NBC, 2016. Rainwater harvesting for plotted/group housing developments. The rainwater harvesting methods adopted for this case are through collection of rooftop rainwater and surface runoff harvesting. A network of rainwater drains in the entire residential area is used for harvesting rooftop rainwater and surface runoff. Filters are used to remove fine particles of dust/bacteria from rainwater. Their selection depends on various factors such as purpose of use, quality of runoff, type of catchment, amount of silt load and type of recharge structure. Mehta, 2015. Hydrocyclone filter is used in Shilpa Hostel in Jainchua College of Engineering, Ananthapuram, South India, which is a low-carbon galvanized steel cylinder with a mesh size of 250 microns. It is enclosed in an outer casing of polyethylene and it can withstand a rainfall intensity of 75 mm/hour. Mehta, 2015. Filter working is based on the principles of cohesive and centrifugal force. It is a static and simple to operate, usually used for phase separations, including solid-liquid, liquid-liquid and liquid-gas separations. They do not have moving parts and they have relatively low capital and operating costs. Mehta, 2015. Suitable up to ARAE. In alluvial areas where the rocks with interconnected pores, i.e., permeable rocks, are bare open to the land surface or are present just below the land surface at a shallow depth, then rooftop rainwater harvesting can be done through recharge pits. The recharge pit technique is adaptable for a roof area of 100 square meters and is an efficient method of recharging the shallow aquifers. Dagwal et al., 2016. Recharge pits may be of any shape and size. Generally circular shape is preferred and the diameter of the pit varies between 1.5 m to 3 m wide and 2 to 3 m deep, which are backfilled with boulders, 5 cm a 20 cm, gravels, 5 mm a 10 mm, and coarse sand, 1.5 mm a 2 mm, in graded form. Boulders are at the bottom, gravels in middle and the coarse sand at the top, and for smaller roof area, pit may be filled with broken bricks or cobbles. Dagwal et al., 2016. Adoption of mesh results in prevention of leaves and other debris entering the recharge pit, and also a desilting chamber can be provided at the ground level to inhibit the flow of finer particles to the recharge pit. Monitoring rainwater harvesting using IoT, Internet of Things. Introduction. At present, the 21st century core problem faced by the world is water scarcity. The best way to get rid of it, to wisely catch the water, comes in the form of rain and drain them responsibly. The available ways of collecting rainwater are housetops, land surface, or rock catchments. One of the most important underlying values in rainwater harvest is that it's an interesting technology and can't produce undesirable consequences. Chandrika Kota et al., 2020. With the dawn of the Internet of Things, IoT, from the Internet as a web service, an extensive number of devices, objects, and environment are becoming smarter and are capable to interact with one another more than ever before. One of the areas which can be greatly improved by the Internet of Things technology is water management. Integrating smart technology in the water industry helps to make all the cities in the world smart cities in the near future. The Internet of Things offers new solutions for improving water management to maximize efficient use of this precious resource. Comprehensive water management strategies can reduce water costs by up to 20%, which can have a major impact on cities. Kumar, 2019. IoT enables us to execute the water harvesting system by database decision-making, real-time monitoring of parameters, trend analysis, etc., which helps optimize water use, cost control, effective reuse, and manpower reduction. Kumar, 2019. Benefits of smart monitoring of rainwater using IoT. Water monitoring system based on wireless sensor networks is a smart system for controlling the wastage of water by using an ultrasonic sensor to sense the level of water in tank. If the water tank is full or up to the maximum level, the sensor will sense it and stop the system automatically. If the water tank is at the minimum level set by user, the sensor will sense it, activate the motor pump at the maximum level. Kumar, 2019. A smart rainwater harvesting system for analyzing water quality comprises of a smart network-connected device which is attached to a few auxiliary tanks through electronic valves. It consists of 3 tanks, one is for clear water, one is for moderately clear water and one is for least clear water. LDR, light-dependent resistors, sensors judges the clarity of the rainwater. Once the tank is full, ultrasound sensor linked to the LDR will beep in order to alert authorities that the tanks are full. Finally, with the help of auto-segregation, water in different tanks are put to use for different purposes. Kumar, 2019. The use of low-power wide area, LPWA, Internet of Things, IoT, devices provide significantly greater water management capabilities. LPWA water meters replace mechanical flow meters, typically serving individual properties. These IoT devices are affordable, small and powerful sensors that can be installed across the water value chain to accurately monitor the flow and use of water, the location of leaks and even the quality of the water being pumped. Kumar, 2019. Efficiency increase. Water management companies and associations can use real-time operational control to make smarter business decisions and reduce operating costs. An IoT-based reference architecture uses sensors and actuators to monitor and improve water management infrastructures, making them more efficient, reducing energy costs and minimizing human intervention. Ganaju et al., 2019. Productivity increase. Productivity is a critical parameter that affects the profitability of any organization. IoT allows real-time control, new business models, process optimization, resource conservations, service time reduction, and the capability to do all of this globally, reducing the mismatch of required versus available skills and improving labor efficiency. Ganaju et al., 2019. Requirements for reference architecture. The following requirements were put down by IJERT, International Journal of Applied Science and Computations, in order to establish a fully working water management model. The Arduino UNO R3 is a microcontroller board based on a removable, dual inline package, DIP, 8MG328 AVR microcontroller. It has 20 digital input/output pins, of which 6 can be used as PWM outputs and 6 can be used as analog inputs. Programs can be loaded onto it from the easy-to-use Arduino computer program. The Arduino has an extensive support community, which makes it a very easy way to get started working with embedded electronics. The R3 is the third, and latest, revision of the Arduino UNO, Ganaju et al., 2019. Water sensor. A water detector is an electronic device that is designed to detect the presence of water and provide an alert. A common design is a small cable or device that lies flat on a floor and relies on the electrical conductivity of water to decrease the resistance across 2 contacts. The device then performs the task specified by the Arduino UNO R3. The sensor is basically a board on which nickel is coated in the form of lines. It works on the principle of resistance. Ganaju et al., 2019. If there is no rain, the resistance between the wires will be very high and there will be no conduction between the wires in the sensor. If there is rain, the water drops will fall on the rain sensor, which will also decrease the resistance between the wires, and wires on the sensor board will conduct, thus triggering the connected DC motor. Ganaju et al., 2019. Ultrasonic sensors. There are total 5 levels in the ultrasonic detectors. Level 1 if the water in the water tank is the same or less than 2000 L. Level 2 if the water in the water reservoir is the same or less than 4000 L. Level 3 if the water in the water reservoir is the same or less than 6000 L. Level 4 if the water in the water reservoir is the same or less than 8000 L. Level 5 if the water in the water reservoir is the same or less than 10,000 L. The ultrasonic sensor will read information about the water level according to its level, and the information through microcontroller will be sent to the database through the internet. The information will be displayed on the mobile application, Untitled, 2021. Flow sensors. Water flow sensor consists of a copper body, a water rotor, and a Hall effect sensor. When water flows through the rotor rolls, its speed changes with different rate of flow. And the Hall effect sensor outputs the corresponding pulse signal. SEED, 2021. It is an open-source IoT software to store and retrieve data from things using HTTP and MQTT protocol. IN is an open-source IoT software to store and retrieve data from things using HTTP and MQTT protocol in Internet or a local area network. Chandrika Kota et al., 2020. It allows to create sensor logging application, location tracking, and it also Internet or a local area network. ThingSpeak allows to create sensor logging application, location tracking, and it also updates the current status. We can find this ThingSpeak in MATLAB with MathWorks account, Chandrika Kota et al., 2020, 3.6. Upon sensing the rain droplets, the water sensor activates and begins to send signals to the attached servo motor. A servomotor is a rotary actuator or linear actuator that allows for precise control of angular or linear position, velocity, and acceleration. It consists of a suitable motor coupled to a sensor for position feedback. This sensor is in turn connected to the sliding door on the surface of the ground that slides open to reveal a collecting container for purpose of catching impending rainfall. As the rainwater collects into this container, signals are actively sent to the harnesser to denote water levels. On the events of overflow of rainwater into the container, the door automatically closes after alerting authorities that the container has been filled to the brim. This rainwater collected is finally used for various human activities. Impact of IoT on rainwater harvesting. Day by day the shortage of water is increasing because of lack of monitoring, maintaining the costs, controlling, and etc. These all are the major reasons why there is increase in shortage of water. To overcome this, IoT applications for smart water management system was developed/was brought into picture. Kumar, 2019. When talking about impact, we mainly focus upon the advantages, so here IoT plays an important role since it helps each and every object, person, or any other device to connect to the internet and helps to exchange the information. Kumar, 2019. Future scope of technology. Rainwater which is stored can be used in many ways. For example, if we want to use the stored rainwater for gardening and watering the plants at a particular time, then we can set an alarm to disperse the water where we want. And this will be the great advantage for us because we are watering the plants with zero effort. Ganaju et al., 2019. The tanks and all the sensors which need power for working can get the power from solar panels which are exposed to the sunlight to collect the energy from it and converts it into the electric power which can be used by the sensors and all. Ganaju et al., 2019. The future work will be camera monitoring to monitor the damages occurred in the pit. Human alert method was vigilance when the humans crossing the pit. This can be also done by using IR, infraradiation, sensor, J.Vino J and Gavaskar, 2018. 4 case studies. 4.1 Atlas Villas, Azrau, Morocco. Geographical description. Azrau is a city located on the western slope of the Middle Atlas at an altitude of about 1,250 m, about 80 kilometers from the city of Fez. Design, 2020. Rainfall data. Rainfall and precipitation data was extracted from Mateo Blue, a website working with databases for the past 30 years to get accurate predictions. Design, 2020. Valve 1 is a one-way valve also known as a check valve. It allows fluid to flow in one direction only. These industrial valves are automatically activated by the force produced by the flow of the medium itself through the pipeline and can be classified as an automatic valve. Design, 2020. The control system, that controls the flow of municipality water, can either be automated, A control valve. The automated system consists of an ultrasonic distance sensor placed at the top of the tank to calculate the distance to the water level. Once the water level drops to the maximum height, a signal is sent to an Arduino board to control and open the valve for municipality water to flow in. There are two drainage points at the roof connected with the PVC pipes. The PVC pipes are further connected together using a T-point at its two different ends at the ground side. One of the PVC pipe would be connected at T-point with a little slope. The third end of the T-point would be connected to the ground system with a U-curve. This curve leads settle down dust particles at one end of the U-curve before raising the water into the other side. The LDR and turbidity sensors are fixed at the U-point using a suitable mechanical arrangement, so that they are properly exposed to the rainwater. The ground system would be mounted in between the PVC pipe and the groundwater tank using a suitable mechanism. The water would be segregated in groundwater subsystem. There would be two outlets from ground subsystem. First outlet would be used for dirty water to direct it towards the ground for purpose of gardening. Second outlet would be used to direct the clean water to groundwater tank. A water pump would be used to pump the water towards rooftop water tank. The ground system is using the IoT technology for communication and powered using the solar panel to make it self-sustainable. Case study analysis. In both the case studies, the proposed system was powered up using solar panel, which makes them self-sustainable. They are economical viable, as in both the cases it saved the considerable amount of money spent on energy of transportation of water from municipal supply and pumping of water from underground aquifers. The system was successful in lowering water consumption demand in the households, by the usage of non-potable harvested water, and limiting the demand on natural water reservoirs. The demand reduction on water consumption in both the cases was found to be more than 50%. The IoT-based quality analysis done using turbidity and pH sensors in case 2 was helpful in segregating and storing water on the basis of its contamination level, and recycling it for various potable and non-potable purposes. Further, if the system is implemented on the larger scale, townships would help in preventing the flooding of rainwater and proving larger catchment areas. Design and implementation. Design of rainwater harvesting for residential housing at Noida. The segregation of water is done in a way that if the pH value falls between 6.5 to 8.5 and turbidity value is less than 5 NTU, so the water will be diverted to the domestic supply tank. This tank is integrated with municipal supply line so that in case the stored rainwater level falls, it is automatically detected with the help of ultrasonic sensors, and then the supply is taken from municipal supply. The control valve integrating the municipal supply and rainwater supply will be automatically operated by the user through Arduino microcontroller. If the rainwater pH and turbidity does not fall under drinking water standard, then it can be diverted to the other tank, from where it can be recycled to horticulture, flushing and fire hydrants. The system can help in reducing the dependency in municipal water supply, and there will be proper recycling of rainwater. Outcomes. Recommendations. The first system is feasible for recharging of water and regulating the overflooding of the rainwater, storing it and recycling it for various purposes, so the system can be adopted in the region where the groundwater has depleted to the level of concern. The second system is suitable where the quality of the rainwater is good for drinking, since there the stored rainwater is integrated with municipal supply line. The system can help in bringing down the dependency on groundwater supply. The future work can be camera monitoring. It is nothing but just watching the level of pit and to monitor the damages occurred in the pit. Human alert method was vigilance when the human crossing the pit. This can also done by using IR sensor. Conclusions. The IoT-based rainwater harvesting provides better results for collection and recycling of rainwater. It helps in solving most of the problems of traditional RWHS. There is fast replenishing of groundwater due to illegal boring is not being recharged by rainwater, which results in the depletion of groundwater to alarming levels, so the proposed design helps to retain the quality of precious rainwater and also to collect rainwater in areas of small size houses. The proposed system reduces the labor cost and it immediately track the changes occurring in real-time monitoring such as lack of visibility into distribution, collection, distribution, and consumption patterns, leak detection, overflow/insufficiency in the pits and tank etc. results in time-consuming, costly and reactive services. To minimize these losses, and to address mounting concerns about drought, flooding, and water quality, water industry is now adopting advanced sensor and communication solutions designed specifically for smart Internet of Things, IoT, water management. The tanks and all the sensors which need power for working can get the power from solar panels which are exposed to the sunlight to collect the energy from it and converts it into the electric power which can be used by the sensors and all. The collected rainwater can be recycled for various purposes such as horticulture, car wash, road wash, flushing, and if it fulfills the quality parameters so it can be used for potable purpose also, hence it can reduce the dependency on municipal supply and groundwater can also be conserved. One of the disadvantage of the people need to have active internet connection for getting the data in mobile application or desktop through cloud, and if the sensor goes down there is no indication to that, manually the owner has to detect it. The proposed IoT-based water controlling and monitoring can be applied to other water networks such as in irrigation to improve system efficiency and sustainability by better management of the water resources.